are live. Okay, so before we do anything, let's talk about what a periodic function is. So, objective, we're going to talk about periodic functions. It's basically where the graph or the pattern repeats along the x-axis, okay? The one, sorry it's so sloppy, okay? So it's a periodic function is simply where the pattern repeats along the x-axis. The one we're going to study the most, and it's not for about a month, is the sine curve.
Like sine as in sine of the hypotenuse, or just sine?
Yes. Sine as in the sine function. Which comes, did you guys see the unit circle at all? Did we look at the unit circle?
Yes, we did.
Yeah.
Oh, like the equation for the circle?
With the big
Yeah.
circle and then all the lines.
Yeah, yeah.
The x, like the x squared plus 1 squared equals.
Yes, you know that. So,
And then you have to write all the numbers in.
Was this something
right, on the
yesterday?
x-axis, which was the pi fourths, the pi halves. Remember that at all?
When was this?
So don't worry, we're going to go back through the whole thing in about a month.
Oh, this is yesterday.
Right, no, this was like last year. So if you don't remember this, don't worry about it. Don't worry about it at all. Because we're going to talk a lot about this in about a month. So here's the thing. Think about a wave, an ocean wave. It keeps going, doesn't it? Right? This is one curve, so that's the period. One curve is the width of one curve, okay? So that's the period. All right, let me go ahead and write some of these things down. So this is my period. And it does keep going, right? Keeps going, keeps going, keeps going. And the number of curves is called the frequency. Number of curves is called the frequency. And we see this in everything. Your cell phones. Maybe electronics use a microwave signal that travels in waves. And the reason when your phone goes off and mine doesn't is it's a slightly different wave. You've got a little antenna inside your phone that picks up that signal. In fact, right now we are being bombarded by umpteen bazillion waves. We really are. I hate to tell you, but right now we're being bombarded by lots and lots and lots of waves, right? But our phones aren't going up, right? Or maybe they are because somebody might be calling the birthday girl, right? So every wave is slightly different. So if we were to change the height, that's going to be an amplitude change. Taking my drawing, and if I took this curve and went 2f of x, right, just twice as tall. It didn't change the width, right? It just changed the height, the amplitude, on both positive and negative. Okay?
So wait, how would you change the width?
Oh, we're going to do that next. Great question. Yep, we're going to do that next. So, if I did this, if I did f of a of x, if I say I went to this equation, and inside changes the frequency, okay? It changes the frequency. So you got to be a little careful. We'll put a little star, and it's going to be the opposite of what you think. So if you, Kai said it really well, and I'm going to write it up here. Jen, you asked a good question. So if I took this curve and I wrote y equals f of 2x on that curve, here's one full roller coaster ride. You with me? Think of it as a roller coaster ride. You're done, right? You get off. if I change the frequency, I need two of these curves in this space. So it's going to look like this. Okay, I got two of them. See how that works? It didn't make it wider, did it? Two inside did not make it wider at all. In fact, it did just the opposite. It did half as wide, right? The book showed this one, which I think is interesting to look at. The book showed this one. I like this one. So what I need is half a curve. So it's going to look like this. Trust the fact I'm a bad artist, okay? And it's squeaky. So really, only have half a curve, but it's the opposite, make it twice as wide to have half a curve. How am I doing? Am I doing okay?
So is there like a specific one for the period besides like just the curve? Because with half a curve, you have a much longer curve and two periods.
Right.
I mean, two periods.
Right, and I'm going to answer that question by saying it depends. You're going to know what the original period is today by just looking at it, okay? When we start to do trig graphs, it's going to be within the equation. For example, and I know you're going way ahead. If you grab, and you do this even on decimals. Y equals, say, 3 sine of x, okay? One curve is going to be 2 pi. Okay, but you're way ahead of it, okay? For today, Lauren, we're going to look at the picture. You can see the picture, okay? This is setting us up for this stuff, which is coming probably around Christmas, okay? Maybe 2 months.
Oh, yeah,
Maybe
Christmas
2
present.
months.
What a Christmas present.
I won't know about
Trigonometry.
trig. In fact, the truth is, half of this class is trigonometry.
Yeah.
You're like, how much trig can you learn?
All of it.
Pick up your cell phone. There's a lot of trigonometry out there, right? And it's not triangles at all.
I like cell phones a little less now.
It's going to be awesome. It's going to be fun. Okay, now, so periodic function, so the period is the width of one curve. So if this were truly a sine curve, the period's 2 pi. Does that make sense? The amplitude is how tall, right? And whatever the height of this thing is, let's say it's 3. So in this example, the amplitude is 3. Okay, how am I doing? An application in sound waves, this is a cool application, right? The application we're talking about is this. If I talk really loud, I did not. I changed that amplitude. Think about this. Really loud sounds hurt our ears, don't they? Because they are big waves. And sound travels through waves. So from me to you, it's traveling through a medium of air. It's kind of weird to think about that. But think about the application. Think about the and now think about just an example of that. If you hit like a huge tsunami is caused by a gigantic disruption in the ocean floor, and you get these gigantic waves, and they hit hard, right? Okay, here's another application. This is a really low frequency. This is a really high frequency. So, my first example was really long waves, and they vibrate your eardrums slowly. And my next example is really high waves, so they're really fast. And your drums are going like this, right? Okay, got it? It's actually pretty easy, isn't it? When we get to this, I'll actually get an oscilloscope, and I'll get a microphone, and you guys can talk into it. You can see your sound wave. And then if you can hold a note, if you'll see a really nice wave. If you can hold a note. All right.
Time to join choir time.
There you go. Okay, so let's take a look at this. So, Lauren, I'm going to answer your question, okay? So for today, Lauren, they're going to give you a picture. So
She can have to finish.
what's the amplitude? Just look at the picture. What's the amplitude?
Amplitude is 2.
Good. And what's the period?
Period is.
Can you match that?
Perfect. You got it. That's it, right?
Really?
That's it.
Yeah,
Yeah.
and I was,
So-
on their
So the amplitude on this one is 2. Sorry, my bad. 2 to negative 2. So the amplitude is 2, and the period is 4. Everybody agree with that?
Did you write amplitude as
You
plus
play
or
the
minus
trombone?
2 or whatever?
No. Great question. It's always a positive number. Thank you. So I know our period is going to be 4 because, and in fact, I'll show you an easy way to see this. If I write one curve, there's one curve. How wide is one curve? 1, 2, 3, 4. And then the period, and then it repeats. And then the period is 4, and the amplitude is 2, okay? Now, this goes forever, f of 3. F of 3 is easy, right? That, remember f of x? I was talking to my algebra kids about this, and they were really confused. But, right, f of x, f of x, right? X, right? Right?
Yeah.
That is a
And
x. So we go to 1, 2, 3. What's the answer?
0.
Good,
Zero.
because same thing I teach them, f of x equals y, so then
So, yeah, I don't think.
it would equal the y value. Okay? Now, f of negative 2, what's f of negative 2?
Negative 2.
Okay?
It's not because.
So f of 3, 1, 2, 3, 1, 2, 3 is 0. F of negative 2 is negative 1, negative 2 is negative 2, good. F of 99, Lauren, you're totally correct, because this repeats. Every 4, this repeats. So we can slide the whole curve back if we just take our period, which is 4, and divide it into 99, right? So 4 goes to 99. How many times? Well, it's like, it goes in evenly. Let's see, 9 divided by 4 is 24 with the remainder. 24 with the remainder of 3, okay? So if you slide the whole thing back, right?
It was a remainder of 2.
Oh, I divided wrong. It's okay, it's all good. 4 times 24 is 96. Remainder 3. There you go. My bad. It's Friday. So that means if you pull the whole thing back, right here is 96. Right here would be 96. That makes sense? 97, 98, 99. It'd be 0. F of 99 is 0. Does that make sense? Pull it all the way back. Okay, turn the page.
Is there a way to solve it without the long division?
No. Yes, Ellie.
Would it just be a
Well, with a period of 4, maybe. In this case, maybe. With a period of 4, yeah. Yeah. The odd numbers are either going to be 2 or 1, 0, 1. Yeah, the odd numbers are going to be 0. Yeah, I'd agree with that. Yeah. Totally agree with that, Ellie. In this case, yes. Okay, turn the page. Now, here's my function. So like I said, Lauren, it'll be given to you. They say it's periodic, so it keeps going, 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 it keeps going. Because it's periodic, right? And it keeps going, it keeps going, it keeps going. It's periodic, okay? But all we need is one curve to really talk about what we're doing. So one curve is the length of doing it over and over again. So if I start here, down, up, down, I would be starting again right, let's see, down by the 0, right? Yeah, be starting again right here because I'd start heading down again, right? So hard, so ignore that. Where's my whiteout? There we go. So, what's the period of this function? How wide is it? Period is, let's see, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My period's 10, right? My amplitude, what's my amplitude? 2, everybody agree? Okay, that's pretty easy. So, let's take this curve, and what does this say? What does this say? We're going to move it. Let's move our curve. How are we going to move it?
Make it half as.
You're going to move it over 2 and up 1.
We're gonna move it to the left
Left 2.
and up 1. How, you guys know why it's left?
Left
Okay.
6.
Yep, and up 1, so I'm gonna take, let's see, 2, 1, so left 2, so I'll take this middle point, 2, and then up 1. So I'm going 1, 2, here's my little thing there. I'm gonna go 1, 2, and then all the way, really, 1, 2, 3, and there it is. And then I'm gonna do the same thing here. Okay, does that make sense? So I just moved it, just shifted it, and up 1. What's this one say?
It's gotta have an amplitude 3.
So yes, so it's 3 times as tall, perfect. So it does. So now it increases, so it triples the amplitude. Okay, so let's see if I can graph that.
So outside is amplitude, inside is
Frequency,
frequency.
yes. So this graph just has to go twice as tall. So this point here, which is at 2, is now going to go up at 6, right? So 2, 4, 6. Right here at 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5. The height is 0, so 3 times 0 is still 0. Does that make sense? So 1, 2, 3, 4, 5. So it doesn't change its width, only the amplitude. Okay. I'll do the same thing on the other one. 1, 2, 2, 4, 6 goes all the way down to here. 1, 2, 3, 4, 5. You guys got it? Does that make sense? Okay. And then finally, last but not least, the 2 on the inside changes the frequency, so it really makes it half as wide so that we can have 2 curves in 10 spaces. I say 10 spaces because that's our period, right? So I'm going to go ahead and take this picture to make it half as wide. I know for sure 0, right? And I'll keep showing you. So the easiest way for me to do it, this is an important point, right? Because that's like a stop point, right? So I'm going to bring it into here. I'm bringing it half as wide. So I'm going to bring that point into here, okay? This is 1 square, but it's going to be half a square. See how I'm doing that? Okay, this point right here is at 1, 2, 3, 4, 5. So this point's going to go into 2.5. 1, 2.5, right? I'll do the same thing on the other side. It's going to go here, and then here, and then it just yeah, and then it just keeps repeating itself. Let's see how bad I am at drawing this, but I'm not very good at this, but okay. Terrible drawing, but there it is. Supposedly I have 2 of those curves in 10. If I was an artist, right? But you got the idea, right? It's so much easier with a sine curve. So this is all I have. I would suggest also on the homework, because it's got some A, B's, and C's. For me, it's easier to use colored pencils, because then you can show all of them kind of on one graph. If you draw